Hello, everyone. Welcome back to the SysGuides YouTube channel. In this video, I'll show you how to install a guest virtual machine using the command line interface in KVM. KVM allows you to install a guest virtual machine using either the graphical interface or command line interface. Installing a virtual machine through the command line interface is especially useful if you're running a minimally configured Linux distribution as a KVM host without a graphical interface. Even if your KVM host has a graphical user interface, you may prefer to install a guest virtual machine using only the command line interface. So the way to install a guest virtual machine from the command line is through a serial console using the Virt-Install tool. Interacting with a serial console is similar to using text terminal without a graphical interface or a mouse. Generally, the first serial port on the guest virtual machine that is /dev/ttys0 is used for the serial console. So in this video, I'll use Fedora 39 workstation as the host machine and Debian 12 as an example of a guest virtual machine. So let's begin. The command is sudo virt-install --name, the name of the guest virtual machine. It must be unique among all known guests of the hypervisor on the connection, including those not currently active. I will name the guest virtual machine as Debian-12-minimal. You can name it whatever you want. --memory, the amount of host memory you want to allocate to the guest virtual machine. To find out how much total memory is available and how much is free on your host, use this command. As you can see, I have a total of 16 GB of memory on my host system. I will allocate 4 GB of memory. If you only want a fixed memory of 4 GB and no hot plugging feature, you can simply specify the amount of memory in MB. But I'd like to enable the memory hot plugging feature in the guest virtual machine. So the way to do it is first specify the maximum amount of memory that you would like to hot plug into the running guest virtual machine. I will set the maximum amount of memory to 8 GB. And then I will set the current memory to 4 GB. By doing this, when I boot the guest virtual machine, it will start with 4 GB of memory and an additional 4 GB for a total of 8 GB available for hot plugging later. Once I've finished creating the guest virtual machine, I'll show you how to dynamically increase or decrease the memory of the virtual machine. --v CPUs, the number of virtual CPUs to assign to the guest virtual machine. To determine how many CPUs the host has, run this command. As you can see, I have 4 CPUs on my host system. I'm running an old 4th generation Intel i5, which has only 4 CPUs. If you have a newer processor, you will have more CPUs. If you want a fixed number of virtual CPUs, say 1, you can just enter that number here. But I would like to enable the CPU hot plugging feature in the guest virtual machine as well. So first, specify the maximum number of virtual CPUs that you want to hot plug into the running guest virtual machine. I'll just set it to 3 CPUs as my maximum is 4. You can, however, change this based on your processor's CPU count. And then I will set the default virtual CPU count to 1. By doing this, when I boot the guest virtual machine, I will start with just 1 virtual CPU with an additional 2 virtual CPUs for a total of 3 virtual CPUs that I can hot plug later. Once I've finished creating the guest virtual machine, I'll show you how to dynamically increase or decrease the virtual CPU count. Next is CPU. Here you can configure the CPU model for the guest virtual machine. The model can be specified either by specifying the exact CPU model or by specifying the mode. If you want to know which CPU models are supported by your host, run this command. These are the CPU models that my host supports, which I can use on a guest virtual machine. Yours could be different. If you want to specify an exact CPU model, such as Core to Duo, you can simply enter it here. Virt-Install will automatically copy CPU features available on the host in order to mitigate security vulnerabilities. You can also force, enable, or disable a specific CPU feature if you want. For example, disable the VMX feature. There is also like a better way to specify the CPU model by using the modes. To find out the modes that are available on your host system, run this command. Of these modes, the 2 important modes are host pass-through and host model. When the mode is set to host pass-through, the host CPU's model and features are exactly passed on to the guest virtual machine. For example, if I set the CPU to host pass-through, the guest virtual machine will have the same CPU as in my host, which in my case is an Intel Core i5 4590. This is the recommended and default option as well. And the disadvantage is that live migration to different hosts with different hardware will be impossible. You can also set the mode to host model. In the host model mode, a CPU model similar to the host CPU is first chosen from the CPU models list. Then, to get as close as possible to the host CPU, additional features are added. To find out which CPU model and features will be assigned to the guest virtual machine, then run this command. For me, it is Haswell, and yours will be different depending on the processor on your host. This will not exactly match the host CPU like host pass-through, but it will provide many of the benefits of host pass-through while also making live migration safe. For this demonstration, however, I will use the host pass-through mode, which is also the default. The next component is about the network. Here you can choose how the virtual machine should connect to the host network. When libvirt is connected to a system instance, there are 3 options for connecting the virtual machine to the host network: a virtual NAT network, a bridge network using a bridge device, or a virtual bridge network using Mac VTAP. when you install KVM virtualization, a virtual network named default with NAT is automatically created. Virtual machines that use this default network will be assigned an IP address between this range. The virtual machines on the default network, however, will only have outbound network access. This means that virtual machines will have full network access, but devices outside the host will be unable to communicate with virtual machines on the host. Only the host computer will have complete access to the virtual machines. The virtual machine, for example, can browse the internet, but cannot host a web server that is accessible to the outside world. Not even from your own mobile device on the same network. Only the host computer and, of course, other virtual machines connected to the same default network can access the web server. From a security standpoint, this network is the best option because you have exclusive access to the virtual machine. To set up the default NAT-based virtual network, simply type in network equals default. If you want virtual machines to be directly visible on the same physical network as the host and also accessible to external devices, you must use a bridge device. But before you choose this option, make sure you've already established a network bridge connection on your host. If you haven't created a network bridge yet and want to do so on your host computer, check out my other video on how to properly install KVM on Linux. In that video, not only did I explain how to create a network bridge, but also how to connect it to the KVM network. Virtual machines that use this bridge device will get IP addresses from the same pool as your host computer. To set up the network bridge, simply enter bridge equals and the name of the bridge connection. For example, bridge 0. If you've also defined a virtual network in KVM by importing XML and giving it a name, you can use that name to set the network bridge instead. If you don't want to go through the trouble of creating a network bridge, but still want the virtual machine to be accessible from the outside world, including other devices on the same network as yours, you can use the Mac VTAP option. When you use the Mac VTAP option, the virtual machine will also get an IP address from the same pool as your host computer. However, keep in mind that your host computer must not have any network bridges configured for this to work. Your virtual machine will be accessible from the outside world, with the exception that your own host computer will not be able to access the virtual machine. For example, suppose you run a web server on your virtual machine and set up the network to use Mac VTAP device. The web page you hosted on your virtual machine will then be accessible to the outside world. The web page is also accessible to other devices on the same physical network as yours, such as your mobile phone. The only computer that does not have access to the virtual machine is your own host computer. You cannot ping the virtual machine from your host, nor can you SSH in. You should work directly on the serial console. This is the difference between the Mac VTAP and the network bridge. To set up Mac VTAP, simply enter type equals direct source equals name of the network device. In my case, it is ENP2S0. For this demonstration, however, I will use the default NAT network. Next is location. The location of the distribution tree installation source. Here, you either enter the path of the ISO installer image if you downloaded one, or enter the URL of the installation tree. If you want to do a network install, because I've already downloaded the Debian ISO installer image, I'll just enter the path of the ISO. To determine whether the ISO file is a valid operating system installation image, run this command. As you can see, the ISO is indeed a Debian installer. Next, OS variant. Specify which operating system the guest virtual machine should be optimized for. To get a list of the accepted operating system variant names, run this command. As I'm installing Debian 12, I will use the Debian 12 ID -- disk. Here you can configure various storage options for the guest virtual machine. Size equals 40. Sets the disk size to 40 gigabytes. Format equals QCOW2. Sets the disk format to QCOW2. It stands for QEMU copy on write. It uses a disk storage optimization strategy that delays allocation of storage until it is actually needed. Other options may include RAW, VDI, VMDK, and so on. But keep in mind that internal snapshots are only available for the QCOW2 type. Cache equals none. This indicates that the host cache must be bypassed. Reads and writes take place directly between the hypervisor and the storage device. This is also the recommended one. Other options include write back, write through, unsafe, and direct sync. Discard equals unmap. When you delete files in the guest virtual machine, the changes are immediately reflected in the guest file system. However, the QCOW2 disk image file associated with the guest on the host does not shrink to reflect to the newly freed space. With the unmap option enabled, the virtual disk size will automatically shrink to reflect the newly freed up space. The next important option that should be added is TPM, which is a trusted platform module. The TPM technology is designed to provide hardware-based security functions. The device could be a TPM pass-through or a TPM emulator. TPM pass-through allows a single virtual machine to access the host's TPM. The TPM emulator, on the other hand, allows each virtual machine its own private TPM. I'll set up the TPM emulator here. Model equals KVM supports two models, TPM interface specification, that is TIS, and other is command response buffer, that is CRB. Both support versions 1.2 and 2.0. In this video, I will enable the TPM emulator with CRB version 2.0. TPM CRB, type equals emulator, and version equals 2.0. The next one is channel. And here you have the option to add communication channel devices that will connect the guest and host machine. There are several channels that can be specified. The one we're interested in is the QEMU guest agent channel. The QEMU guest agent channel establishes a private communication channel between the host physical machine and the guest virtual machine. This allows you to send commands to the guest virtual machine's operating system. The guest operating system then responds asynchronously to those commands. To add the channel, simply enter type equals Unix target.type equals Virt-IO target.name equals org.qemu.guest underscore agent .0. Then graphics. Here you can specify which graphical display you want to use. Typically, you don't need to specify this option. Virt-Install will try to select a useful default, which in the KVM hypervisor is Spice, a graphical console. However, because we are installing the guest virtual machine in a command line interface, and the assumption here is that there is no graphical interface, you cannot assign a graphical console. The graphical console won't work in a command line interface only configuration. As a result, the guest virtual machine must be explicitly configured with a serial console on its first serial port. Using a serial console is similar to using a text terminal, but without a GUI or mouse. To accomplish this, first disable the graphical console by specifying none. Then, using the extra args option, configure the serial console. The extra args option is used to pass additional kernel arguments to the installer when performing a guest installation. The first kernel argument I pass is a virtual VGA console. The first VGA console is indicated by the value console equals TTY0. Although I am not using a graphical console here, I will still include a VGA console just in case you later install a desktop environment in the guest virtual machine and enable graphical console. The VGA console will then become the default console. The next kernel argument I pass is a serial console. The output will be displayed on both of them. TTY-S0 denotes a serial console on the first serial port. The numbering starts at 0. The number 115200 represents the serial port's baud rate in a real-world situation. The baud speed setting of the RS-232 connection is affected by the length of the cable. The higher the baud rate, the shorter the cable should be. Otherwise, the communication will be unreliable. So most of the Linux distributions set the baud speed to 9600, which is considered a reliable and safe baud speed. Since we are using a virtual serial console, a much higher baud rate of 115200 is recommended. N is with no parity bit, and 8 is 8 data bits. I will add a triple dash and then retype the same block again. While the first block is used to pass as kernel arguments to the installer during a guest installation. The same block after the triple dash instructs the Virt-Install command to permanently copy it into the bootloader of the installed guest virtual machine. The changes are made to the /etc/default/grub file on the guest virtual machine. And finally, you should configure the firmware. If you want to use the legacy BIOS firmware, there is no need to do anything. Just press the Enter key to begin the installation. The BIOS firmware will be configured by default. However, if you want the guest to have UEFI firmware, then include the boot option and the UEFI firmware. To begin the Debian installation on the serial console, press the Enter key. A text-based installation will start. Select your installation language. I will select English. Select your location. Set your keyboard key map. Enter a host name for this virtual machine. I will keep Debian. If you want, you can change it. Enter your domain name, if any. I will just continue without one. Provide a root password. Enter your name, your username. Set a password for your user account. Select your time zone. Here you must select how you want to use the disk. To keep things simple, I will use the entire disk. However, if you want to configure the disk in a different way, you have other options. Choose the partition scheme you want. I'll select the one with a separate home partition. Press the Enter button to finish partitioning the disk. And yes to confirm rights to disk. Scan extra installation media. No. Use a network mirror. Yes. No proxy. No. I'll remove the desktop environments because they won't appear in serial console. Use spacebar to uncheck. I will install the SSH server so that I can connect to the guest virtual machine from the host. Press Tab and hit Continue to proceed with the installation. The installation is now complete. Press Continue to reboot the virtual machine. Enter your username and password. And you will be logged into a command line interface within a virtual serial console. If you want to exit the serial console, press the Control plus closed bracket keys. If the text on the host terminal continues to crop, even after exiting the serial console, then use the reset command to clear it out. And to reconnect to the serial console, run the command sudo virsh console, the name of the guest virtual machine, and press enter. By default, the regular user does not have super user rights. So first switch to root user, open the Debian sources list, and remove the DVD repository. Install the sudo package. Next, add the regular user to the sudo group. Then reboot. Now try installing the Vim package. The regular user now has super user privileges. As you can see, the listing is in monochrome. This is because the default video terminal for a serial console will be VT220. So if you want colors in your terminal, you might want to try Xterm 256 color. The command is export term equals Xterm 256 color. Try to list the files again. Now it will be in color. If you want it to be permanent, then add the same command to the bash rc file. And source it. Now, as you can see, the size of the serial console is very small. When you connect a remote device via SSH, the terminal type and host screen size are automatically sent to the remote device. This does not occur when connecting through a serial connection. As a result, you may notice reduced screen size, visual anomalies, and scrolling. That isn't working properly. So if you want to manually change the size, say rows to 25 and columns to 120, run this command. There is one other tool called Resize that comes with the package Xterm in Ubuntu and Debian that adjusts the size of the serial console using the settings from the host terminal window. As you can see, there are now 144 columns and 34 rows. I have set the baud speed to 1150-200 bits per second. You can also adjust the speed. First, determine which TTY you are attached to. Then you can assign the new speed, for example, 9600 to that TTY. The speed is now 9600 bits per second. However, I will revert to the original speed, 1150-200. The next step is to install the guest agent daemon package. Because you have added QEMU guest agent channel to the guest virtual machine, you must also install the QEMU guest agent package. This agent must run inside the guest in order to communicate with the host. As you can see, the package is already pre-installed, so no issue here. As you may recall, we enabled the hot plugging feature for the CPU and memory at the beginning of the video. To demonstrate that, let me first open a new tab so I can run some commands from the host. Let me check how much memory the guest virtual machine currently has. As you can see, the current memory is approximately 4 GB. You can also check the current memory of the virtual machine from the host. And maximum amount of memory I can hot plug is 8 gigabytes. So if you want to hot plug an additional 2 gigabytes of memory for a total of 6 gigabytes, use this command. As you can see, the virtual machine's current memory is now 6 gigabytes. Same thing in the virtual machine as well. When the guest is restarted, the memory will be reset to 4 gigs. If you want the memory to be permanently set to 6 gigs upon boot, run this command on the host. Similarly, you can also hot plug CPUs. When I created the virtual machine, I had set the current CPU to 1 and my maximum to 3. You can also use the command lscpu to get the current CPU count in the virtual machine. So if you want to hot plug an additional CPU for a total of 2 CPUs, run this command. Now check again. The current CPU has been changed to 2. And the change has also been applied to the virtual machine. Similar to memory, the hot plugged CPU will also be reset to 1 after the virtual machine reboots. To make it permanent, run this command. Throughout this time, and you worked directly within the serial console, you can also use SSH to connect to a virtual machine. To do this, first obtain the IP address of the guest virtual machine. By the way, you can use this command to check the partitions in the virtual machine. Anyway, to connect to a virtual machine using SSH, enter the username and IP address. All right, this concludes the video. Thank you for watching. Take care. Goodbye.